let's talk about another problem here. Let's say you're working for Domino's. Okay, let's say you're working for Domino's, and Domino's have to open a particular, not particular, let's say three outlets in a particular city. Okay, let's say a Domino's, you're working for Domino's, and he asks you to help them out to open the Domino's solution, sorry, Domino's pizza uh, places in three different places of the city. And now, what you did, you went to the history of the people, okay, and you make a study there and realize that the people who eat pizza are living in these areas. Let's say you surveyed in online forms, and people said that pizza is their favorite dish, or they eat pizza in a regular or maybe monthly basis. So you saw them and you plotted them out into these locations. Let's say these are the people, and let's say these are some people also. Okay, these are some people, and also these are some people. After an online survey forum, you were able to know this data, that these people like pizzas. Okay, and these are the people in the city who, these are the houses in the city where pizza is being made, or the people really like the pizza. Okay, so we decided that, you told Domino's that these are the people that like pizza, and these are the places that you can that you can find a pizza parlor for. Okay, that you can find a pizza parlor for. As a human, you can simply, let's say, as a human, you can simply say that, these are the three places. But for a machine, it's not that easy. For a human, it's very easy to say that yes, here is a pizza parlor, here's a pizza parlor, here's a pizza parlor. But for machines, that's not easy. That's not that easy. Okay, so we need to build a machine learning algorithm. We need to not build a we need to use a machine learning algorithm to tell the pizza parlor owner that open in these three locations to for a to open the pizza. Basically, these are the people who like the pizza. Okay, so we need to know where are the optimal places to put them, because the place can be here, 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 here. It can be anywhere. But for human brain, your human brain must be saying that this is a perfect place to open it. But it's not that easy for machines. It's not that easy for machines. We need to automate this process. Okay, so it seems that the houses are properly splitted here, as you can see. Okay, and let's say you're having a red area, a blue area, and a yellow area. Let's say you're having yellow area. Okay, and it will make sense to put one pizza parlor into each of these groups, right? One pizza parlor into each of these groups. And as I said, it's not that easy for computer to do that. It's not that easy for computers to do that. So first of all, did you understand the solution here? That how human is able to find a solution instantly? Just by looking at the data, we were able to find the solution instantly, right? So we want to do the same thing for the machines. So let's start by choosing a random location for the pizza. Let's start choosing random locations for the pizza parlor. Okay, so what do I mean by random location? I mean that you want to take three pizza parlor and put it in any random location. Let's say this is one pizza parlor. Okay, let's say this is another pizza parlor, and let's say this is another pizza parlor. We choose a random location in starting, and now we will try to optimize the solution. Let's do one thing. Let's have a little smaller circle. This is for one, so one pizza parlor. This is one, another one, and let's say this is another one. Now these three are the pizza parlors, and now we are going to optimize on the solution. Okay, so first step is choosing the random pizza parlor to put. Okay, remember that always. First step is to choose a random pizza parlor to put. Now, it would make sense to say each house should go to the pizza parlor, right? Each of the house should go to a particular pizza parlor. Okay, and every house is going to choose any one of them, right? Like for a regular basis, if they are doing it, then if they're going to choose any one of them to buy the pizza from. Okay, so it's wise to say that closest houses closest houses are going, the house that are closest to the pizza parlor is going to buy the pizza from. So let's say these are the houses. Let's say these are the houses that are closest to blue pizza parlor. Okay, and these are the houses are closest to yellow pizza parlor, and these are the houses that are closest to red pizza parlor. Okay, so first of all, did you understand this point or not? That every house will choose a pizza parlor, or basically there is going to be the houses that is going to be nearest to any one of them, right? Yes or no? There is all the houses are going to have a pizza parlor that is going to be nearest to them. Yes or no? And based on that, this is your diagram, which is for yellow. For these people, the yellow pizza parlor is nearest. For these people, blue pizza parlor is the nearest. For these people, blue pizza parlor is the nearest. For these is red. For these it's red. Okay, for these it's red. Now it will make sense to, once you find the solution, it will make sense to move the pizza parlor to the very center of its clientele, right? Like, if you have this, then I would say that if these are the people to this for this blue pizza parlor, I should move this pizza parlor to the center of the clientele, because some houses are really far away from it, right? Some houses are really far away from it. So let's move the pizza parlor to the center, right? Let's move this pizza parlor to the center like this, something like this, right? Did you understand this spread? Why I have moved the parlor to the center? Yes or no? Why I have moved the parlor to the center of this location? Tell me, did you understand this part? Okay, once you move that, there is a problem now. Now these people are far away from this blue ones, right? And these people are closest to the red, this yellow one, right? And now these people are closest to the blue one, because this distance is less than this distance. Okay, so now we can color the whole, we can color the pizza parlor respectively based on our understanding. So I can say that these are the parlors that is going to be closest to this red one, and these are some parlors that is going to be closest to this blue one. Okay, so what I'll do, I'll simply remove this. Okay, let's do one thing, let's keep it. Okay, and what you did, you have this with you, and now you are simply going to color them. That means this time these pizza parlors are going to become yellow, right? This is going to lie in the yellow area, and I should say that blue area is going to be this one. Blue area for the blue pizza parlor, this is going to be the one. And for the red pizza parlor, let's remove this circle, and for the red pizza parlor, this is going to be your people, right? Now again, repeat the same process. Move the pizza parlor to the center. Move the pizza parlor to the center like this. It will move here because these are the less data points. So these will move here around. Okay, it will move around center here. And now again the problem arises, the same problem arises, that these people are now closest to the blue parlor instead of red parlor. Okay, so what I'll do, I'm going to simply remove this area and update the parlors here. So this is going to be the clientele of the blue people, and this is going to be the clientele of the red people, and this is almost same. It's going to move a little bit. Okay, so now again the pizza parlor is going to move in between. So this is your pizza parlor and move it in between. This is your pizza parlor and move it in between this. Oh, in between. Okay, now once you repeat the process, you have a proper solution. We got the optimal solution here. Okay, which iterated from a very random solution to an ideal one. Literally, theoretically, you have just seen that. And literally from the random solution, we reached an optimal solution. Okay, so this algorithm is called as K-means. This algorithm is called as K-means. Okay, K-means algorithm. This is the introduction to how K-means algorithm works. Okay, it starts from a random solution, then optimize it based on the data points that is closest to it, and keep optimizing until you find an optimal solution. And in K-means, the thing that you have noticed, that we have to tell how many number of k you want. K you want. Here k means three pizza parlor. That means you knew that you have to put three pizza parlors in the city, right? You knew that you have to put three pizza parlors in the city. That means it has to tell how many number of k's you want. This k is representing the three pizza parlors. Okay, but what about if we don't know how many number of pizza parlors I want, or how many number of uh, k's I want, right? This is a question. This must be a question in your mind, that Samir already knew about three pizza parlors, and luckily we got three sets of people in a separate area, and we were able to plot us three different parlors for them. But what about if you're not able to get how many number of pizza parlors should I put? Then what? Then what we'll do? So let's take that example.
To change your